Today's lesson is on simplifying radicals. So, this is something that we should have worked on in 8th and ninth grade, but we need to review it for our special right triangles. Okay, so for a warm up, I want you to tell me what all the perfect squares are from my doubles. So, if you should know these by heart, is what I'm thinking. But if you don't, another way you can do this is you can put them in the calculator under y equals and do x squared. So 1 times 1 is 1. So 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. We should have these that we're looking for on a regular basis, but know them by heart. Okay, so what is a radical? A radical is the actual symbol here. So this is the symbol called a radical. So the index is here. When I have no number, the index is 2. So radical means root of. So right now, the only radicals I'm talking about right now for special right triangles are where an index is 2. So the index is this number outside the radical, and the information under the radical is called the radicand. So I can say 6 square root of 3 or 6 radical 3. So sometimes I hear it both ways. Okay, so what is the process? For me to simplify, I want to take out the largest perfect square. So to do that, I need to take what my product is, and I want to divide that into factors where one of them is a perfect square. So a perfect square is anything times itself. So when I go from under the radical to outside the radical, I'm squared under and not squared outside, but this is just for where index is 2. Okay, so if I want to know what the products are or what the factors are, I'm going to put in my calculator the product divided by x, and I'm going to go look at the table. All right, so what does this look like? How am I going to do this? So I'm going to I have 24, and I know the factors of 24 are 6 times 4. So I want a perfect square. So 4 is a perfect square. So when I separate that, the square root of 4 is 2, because this is really 2 times 2. So when I take it out from underneath, this becomes 2, and I still have a radical 6, or square root of 6. So when I bring the square root of 4 as 2 out, I just bring these out in pairs. Okay, so if I want to simplify, square root of 72, I'm looking for the largest perfect squares. So I put in 72 divided by x, and I'm looking for the largest perfect squares in this row, and 36 is a perfect square, so I know 36 times 2 are the factors. So I'm going to rewrite this on this side, 36 and the square root of 2, so I can separate my factors. And the square root of 36, so we said this is 6 times 6, right? So I take these out in pairs. So this becomes 6 times the square root of 2. Okay, let's try another one. I want to find or simplify 3 times the square root of 200. I'm going to put 200 divided by x. So I'm looking for my largest perfect square. And I see 100. So 100 is a perfect square. So this is 100 times 2. So this is going to be 3 times the square root of 100 times the square root of 2. So I know 100 is 10 times 10. So when I bring this out, it's a 10. So this is going to be 3 times 10 times the square root of 2. And then now I want to multiply 3 times 10. So this is 30 times the square root of 2. Okay, multiplying or dividing with radicals. So when I multiply or divide the outside numbers of the radicals, and I multiply and divide the numbers under the radicals. So these are kind of like the like terms. Okay, so if I'm going to multiply 2 times the square root of 8 times 4 times the square root of 5, I'm going to multiply 2 times 4, which is 8. And I'm going to multiply 8 times 5. And they'll still stay under the radical. So 8 times 5. So 8 times the square root of 40. Now I want to simplify the square root of 40. So I know the factors are going to be 4 times 10. So I'm going to set up, this is 8 times the square root of 4 times the square root of 10. So this is going to be 8. The square root of 4 is 2 times the square root of 10. And now I need to multiply 8 times 2, which is 16 times the square root of 10. Okay, so next, let's try multiplying 3 times the square root of 5 times 3 times the square root of 5. What happens when I see the same number twice? So I'm going to multiply 3 times 3 and 5 times 5, right? So this is going to be 3 times 3 and 5 times 5. So 3 times 3 is 9, but I don't want to multiply this out because this is actually a perfect square. So this is going to be 9 times 5, which is 45. Okay, and we cannot have a radical in the denominator. So there's no radicals in the denominator. So we say we are going to rationalize the denominator because I'm going to make the denominator a rational number. So I'm going to multiply by 1. So this is 1. The square root of 3 divided by 3 is 1. The square root of 2 divided by the square root of 2 is 1. The square root of 6 divided by the square root of 6 is 1. So anything divided by itself is 1. So I'm looking at whatever is in the denominator, and I'm going to multiply that as my 1. So since I have a square root of 3 in the denominator, my 1 looks like square root of 3 divided by 3. So now I have 2 fractions. So I'm going to multiply numerator times numerator. So this is 2 times the square root of 3. And then I'm going to multiply the denominator times the denominator. So the square root of 3 times the square root of 3 is the square root of 9. But this is really 3 times 3, right? Which is a perfect square. So this is going to be 2 times the square root of 3 divided by 3. So when I'm multiplying here, the square root of x times the square root of x is going to be x. Okay, so let's try another one. So I'm going to start by, I'm looking what's in the denominator, and I'm going to multiply times 1. And 1 looks like the square root of 2 divided by the square root of 2. So now I'm multiplying across 8 times the square root of 2, and the square root of 2 times the square root of 2. So square root of 2 times the square root of 2 is 2. So now I'm going to simplify 8 divided by 2. So this is 4 times the square root of 2. So we are done. This is an important one. And 1 is the square root of x divided by the square root of x. So that's the other fact we really need to use. Okay, that's it.